Welcome to Force in Motion. Today's objective, students are going to be able to define force and motion, but they're also going to be able to define several different terms, including speed, velocity, and acceleration. So the definition of force, a force is simply a push or a pull. All forces have both size and direction. Let's take a look at net force. Net force is when two or more forces are combined. Take a look at this Soyuz rocket. I've got 3 red arrows pointing at each one of the engines that are burning. The force is all 3 of those engines added up that's actually making the rocket go into orbit. Now, balanced versus unbalanced forces. Balanced forces are when the net force on an object equals 0. These do not produce change in motion. Think about it. The gravity is trying to take the skier down the hill, but the friction is counterbalancing it with a net force of 0. Therefore, the skier is not moving. Now in this picture, the skier is moving because it's an unbalanced force. When the net force of an object is not 0, these forces do produce a change in motion. And think about it. Gravity is pulling the skier down the hill, and there is not enough friction to stop the skier. Therefore, there's movement. Now let's take a look at this beach ball real quick. Looks like it's in a great mood sitting still, but look right behind it. The surf's coming, and you know what's going to happen. It's going to be unbalanced forces at that point, and that surf is going to bring the ball closer to the camera. And of course, that means the ball is going to be in motion. But what is motion? Motion is when an object changes position over time when compared with a reference point. We say that that object is in motion. Just like these horses. They started out of the gate, and they're in motion. Now, the motion also has a speed. The rate at which an object moves is its speed. It depends on the distance traveled and the time it takes to travel that distance. Speed equals distance divided by time. There's a difference between speed and velocity. The speed of an object in a particular direction is actually known as velocity. Take a look at these jets. They're changing direction. They're changing velocity. Velocity must also include a direction when you describe it. An example, a jet's velocity might be 500 kilometers per hour going south. Now, velocity changes as speed or direction changes, just like these race cars. As they're going around a turn, their direction is changing, therefore their velocity is changing. And acceleration is different than velocity. The rate at which velocity changes is known as acceleration. To change velocity, you change the speed or direction or both. It's not just how much velocity changes, but it's also how fast it changes. The faster the velocity changes, the greater the acceleration is. Acceleration formula. Acceleration equals final velocity minus the start velocity divided by time. Velocity is expressed in meters per second, and time is expressed in seconds. So acceleration is expressed in meters per second squared. Hopefully you recognize this man. This is Sir Isaac Newton, and he came up with some laws. Newton's first law, an object at rest, just like these arrows, tends to stay at rest. And an object in motion tends to stay in motion unless acted upon by an outside force. And what's associated with the law 1? The law of inertia. Mass is the measure of the amount of matter within an object. Inertia is the property of an object that describes how much it will resist change to the motion of an object. Now, it's an appropriate picture that we're showing a person strap on their safety belt, because if you think about it, if you don't have your safety belt on and the car stops, you want to continue going forward. That's why we wear our safety belt, because of inertia. More mass an object has means more inertia the object's going to have. Look at this battleship. I mean, if this thing's moving, it's going to take a good bit of time to get it stopped, because it's going to have more inertia because it has more mass. Now you compare that aircraft carrier with this toy boat. Toy boat doesn't have very much mass. A child could stop the boat because it doesn't have a whole lot of mass. Therefore, it's not going to have a whole lot of inertia. Now we're going to switch gears and we're going to talk about friction. The first type of friction is sliding friction. And sliding friction is the force that is slowing an object down from sliding across the surface. It's as simple as that. The next type of friction is rolling friction. And what's cool about rolling friction is instead of slowing something down, it's actually making the wheel turn, because it's actually coming in contact with the surface. It's making the wheel grab hold of that surface and making the wheel rotate. It's the same as a wheel on a bike. And as the tire is going around, it's grabbing a hold of the surface, and it's actually making the wheel turn round and round. Now, unlike the prior two types of friction, static friction is what keeps something in place. It keeps it from moving. So the rock actually has friction in between it itself and the earth, and therefore it's not moving. Okay, recognize this guy again? Yep, Sir Isaac Newton. Now we're looking at his second law. Force equals mass times acceleration. F equals m times a. Newton's second law: an object acted upon by an outside force is going to travel in the same vector as the outside force. What does that mean? This baseball player is acting upon a baseball. Okay, the outside force is going to be that pitcher's arm. And that pitcher, as that pitcher actually throws the baseball in a certain direction, that ball is going to go in the same vector, in the same direction and speed as the arm. That's Newton's second law. Once again, Newton's second law: force equals mass times acceleration. Force is measured in newtons. Acceleration of gravity is 9.8 meters per second squared. And here he is again, Sir Isaac Newton. He had a third law. Can you remember what it was? That's right. For every action, there is an equal and opposite reaction. This is a picture of the Saturn V rocket, the largest man-made machine ever devised, probably the most powerful. Okay, what is making that Saturn V get up off of the launch pad? All the thrust is pushing up down against the Earth is being pushed back by the Earth. So it's a really cool idea, Newton's third law here. For every action, there's an opposite and equal reaction. So whenever you have a rocket that's pushing down thrust, the Earth is pushing back and therefore making the rocket go up into orbit. Another great example is baseball. Think about it. If someone is just tossing the ball softly to you, are you going to be able to hit it out of the park? Maybe if your bat speed is tremendous. But think about this. If someone really throws the ball hard and you just stick the bat out, that ball is going to come off that bat much faster. Because think about Newton's third law. For every action, there's an equal and opposite reaction. So if they're throwing the ball hard, that ball is going to come off that bat just as hard. That wraps up today's lesson with force and motion, long distance learning. I hope you learned a lot. Make sure if you did not understand something, go back and rewatch the video and then answer your questions. Have a great day. I'll see you next time.